integrate x cubed over x squared minus x minus 6. Alright, so we've got a rational polynomial. We know how to integrate these with partial fractions. However, the degree on top is bigger than the degree on bottom, so first we're going to do a polynomial long division. Okay, so we set up our long division. X squared goes into x cubed x times. Okay, I'll put some placeholders in here. Okay, now we subtract. So we got x squared plus 6x. Okay, x squared goes into x squared one time. Okay, and subtract, we get 7x plus 6. Alright, so x cubed over x squared minus x minus 6 is really x plus 1 plus, and then we put the remainder on top, 7x plus 6 over x squared minus x minus 6. Okay, what does this mean for us? Well, we're trying to integrate. So first we're going to rewrite by splitting this into two integrals, one of which is a proper rational function, and so we can now just focus on this part here and use a partial fractions decomposition. Now we're going to need the denominator factored. So can we think of two things that multiply to negative 6 and add to negative 1? Negative 3 and 2. Although we could use the quadratic formula if this just didn't come to mind right away. Okay, so a over x minus 3, b over x plus 2, and now we've got to solve for our constants a and b. So we'll multiply both sides by x squared minus x minus 6. And that'll give us this nice expression here. 7x plus 6 is the same as a times x plus 2 plus b times x minus 3. Now we can pick some values for x. So if we plug in x is negative 2, we get negative 14 plus 6 on the left. Okay, we'll get a 0 multiplied by the a. Negative 2 minus 3, so we'll have negative 5b. So negative 14 plus 6, that'll be negative 8, is negative 5b. So b must be 8/5. If we were to let x be 3, we'll get 7 times 3 is 21 plus 6 over here, and then a 3 plus 2. And the reason we chose x to be 3 is so that now b will have 0 to be multiplied by. So we get 27 is 5a, or a is 27/5. All right, so where were we? Well, we've got to integrate x plus 1 dx. That's not going to be hard. Now, we would have 7x plus 6, but we can now replace that with a over x minus 3 plus b over x plus 2. Okay. So we got x squared over 2 plus x. Now we'll split this up. I'm going to bring the constants out. Alright, now it's just a quick question of, can we integrate these? And absolutely we can. We can treat them as some of the building blocks we've seen, or we can just go ahead and do something like a substitution. And there is our final answer. X squared over 2 plus x plus 27/5 ln x minus 3 plus 8/5 ln x plus 2. And we never ever forget our plus c.